Hello all, in this video we are going to learn about Bayesian classification. Bayesian classification is a probabilistic classification method based on Bayes' theorem. It assumes the feature independence, meaning each feature contributes independently to the outcome. It is widely used in data mining, text classification, spam filtering, etc. Bayes' theorem says P of, that is probability of C given X, is equal to probability of X given C into probability of C divided by probability of X, where probability of C given X is equal to probability of class C given the feature X, that is a posterior probability, and probability of X given C is equal to probability of features given class likelihood. Probability of C is equal to prior probability of class C. Similarly, probability of X is equal to probability of features using the normalizing factors. There are some advantages and limitations of this particular theorem. So advantages are it is simple as well as fast, it works well with a high dimensional data, and this algorithm requires relatively small training data. Whereas the limitation says it assumes independence between the features and zero probabilities if a feature never occurs in the training data. These are the few applications I have listed about the algorithm, that it can be used for spam filtering, for document classification, for medical diagnosis, and for sentiment analysis. Now let us check the Bayesian classifier using an example. So over here you can see we have a sample data set of 10 records with 3 columns as ID, symptoms and disease, and we have to predict whether a person has a disease, yes or no. That should be the answer given the symptom as cough. So if the person is having cough, we have to predict whether he will be having disease or not. So you can see there are number of combinations of cough, yes, no is given, fever, yes, no is given. So we'll be using a Bayes classifier to predict whether the person will be having a disease or not if he is having a cough. So let us check now what we have to calculate first. So we will apply a Bayesian classification. So that is probability of disease is equal to yes. Symptoms we have already have, that is symptom is cough. So that's why the given value we already have, that is symptom is equal to cough. And we have to check the probability of disease yes, and we have to check the probability of no when the symptom is given as cough. Bayesian theorem says probability of C given X is equal to probability of X given C into probability of C divided by probability of X. But over here, we will only compare the numerator for the decision, because if I will compare the probability of disease is equal to yes when the symptoms are given as cough divided by the symptom as cough, then symptom cough will be there for both the things, whether it is for yes or whether it the probability of no. So that's why we will not be comparing the denominator, will not be using the denominator, will be only using the numerator for the comparison purpose. So we will be finding the probability of disease yes given the symptom cough. We will be finding the probability of disease no when symptom is given as cough. Whichever is the highest probability. If yes is having highest probability, the answer will be yes. If the no is having higher probability, then the answer will be no. So let us first calculate the priors. So that's the first task. We will be checking how many records are there. So total 10 records are there. Then we will be checking how many times disease is equal to yes is present. So disease is equal to yes is present in 4 records. You can see in ID 1, in ID 4, in ID 5 and in ID 8. So that's why the probability of yes is 4 by 10. 4 is in how many times yes is present, divided by 10 is nothing but total number of records. So that's why probability of yes is 4 by 10, which is equal to 40%. Similarly, we will calculate disease is equal to no, probability of no, that is nothing but in our record how many times no is present. So you can see in second transaction no is present, in third transaction, in sixth transaction, in seventh, in ninth, and in 10th transaction no is present. So 6 times no is present. So that's why probability of no is equal to 6 by 10. 6 times no are present and 10 is total number of records. So that's why probability of no is 60%. Probability of yes is 40%. So this is how priors we first have to find out. So we have checked the priors for probability yes and probability no. The second step is to calculate the likelihood. So to calculate the likelihood, we will check for disease is equal to yes and the symptom is cough. In how many records these both things are present? Disease is yes and symptom is cough. Symptom cough is given in our question, right? So we will be finding in how many transactions we have disease yes with a symptom cough. So you can see we have fourth ID in which cough is present as a symptom and we have disease as yes. Similarly, we have the 8th transaction where symptom is cough and disease is yes. So out of 4 yes, we have only 2 transactions in which we have cough with disease yes. So that's why probability of cough given yes is equal to 2 transactions in which cough and yes is present divided by 4, that is nothing but how many times yes is present. So probability of cough given yes is 50%. Similarly, we will be finding in how many transactions disease no with symptom cough is present. So you can see cough and no in the second transaction and we can see cough with no in the sixth transaction. So out of 6 no's, we have already checked there are 6 no's. Out of 6 no's, there are only 2 transactions in which disease no along with the symptom cough is present. So that's why probability of cough given no is equal to 2 divided by 6, which is approximately 0.333. So we have calculated the likelihood. Now the final calculation is to compute the posterior probabilities. So we have to calculate the posterior probabilities of if the person is having cough, whether he will have disease yes or not. If the person is having cough, whether he is having a disease yes or no. So that we have to calculate. So that's why two posterior probability we will be calculating. Probability of yes given cough is equal to probability of cough given yes into probability of yes. Over here we are only using numerator. Denominator, that is probability of a cough, we are not using, right? Because denominator will be same for both the probabilities. That's why denominator we have not considered. Otherwise, the Bayesian term is having denominator as well. As we are not using denominator, over here I have just assumed it, that is the symbol I have used. Equal to I have not used. Okay. So already we have calculated probability of curve given yes, that is our likelihood. So you can see it is 0.5. So that's why over here you can see 0.5. Probability of yes also we have calculated. So that is a prior probability which is 0.4. So 0.5 into 0.4, that is 20. 0.20. Okay. That is a, you can say 20%. Similarly, probability of no given curve, instead of equal to, I said assume, it is probability of curve given no into probability of no. We can calculate it easily because probability of curve for no we have already calculated. So probability of cup given no is 0.33, and probability of no also we have already calculated, which is 0.6. So prior and likelihood we have already calculated. I have given the value over here 0.333 into zero point 0.6, which is approximately equal to 0.1998. So we have calculated both the posterior probability for yes given cuff is equal to approximately zero point 0.2, and probability of no given cuff is equal to 0.1998. So obviously 0.2 is greater than 0.1998. That means yes is having the higher probability than no. So that's why the prediction will be disease is yes given the symptom cough. So if we have cough, there will be a disease true. So that's about the Bayesian classifier. We have done the calculation and we have given the answer for disease, whether it will be yes or no. So that is the prediction we have calculated using 3 steps. First, you have to calculate the prior, then you have to calculate the likelihood, and then you have to calculate the posterior probability. So thank you all of you for watching this video. If you like the video, click on the like button.